Hi. In this video, I'm going to give you some tips and things to think about as you're studying for the second midterm. Tip number 1, if you're analyzing the runtime of a recursive algorithm, then the recurrence you come up with should really have two parts to it all the time. If you're writing down a recurrence of the form t of n equals, there should be a recursive part which might look like t of n minus 1 or t of n over 2 or maybe 3 t of n over 4, something that looks like this, where each of these numbers are based on the recursive calls in your program. You also need a non-recursive part. And this will look something like d or dn or dn log n. And remember that you can get this term by analyzing the asymptotic runtime of all of the non-recursive steps in the code. Speaking of code, make sure you refer to it. This midterm is going to have a lot of code on it, either code that you read or code that you write. When you're analyzing the code, either for runtime or for correctness, make sure you actually talk about what the code is doing and be specific. One way to be very specific is to use specific line numbers in your proofs. Okay, the master theorem. One more reminder, write it on your cheat sheet because it's not going to be provided to you on the midterm. Most of you seem to be pretty good at using the master theorem. Make sure you're also aware of when you can't use it. So don't fall into a trap of thinking, oh, well, I can just use it all the time, because you can actually only use it for a very specific type of recurrence, which may or may not come up on the midterm. If you have to write a divide and conquer algorithm, remember the three main steps. First, you divide the input into some sub-problems, some problems of a smaller size. And then you recursively solve some or all of the sub-problems. And then you combine the results of all your recursive calls and then return the final answer. This is the philosophy behind every divide and conquer algorithm. Okay, when you're talking about correctness, a very common question to ask yourself is, well, what is this function call doing? Maybe it's a recursive call, for example, and you're trying to figure out what does it do. There's really only two possible outcomes for this. Either you know the post condition of the function, in which case use the post condition to answer what does this function do. That's it, post condition, period. But if you don't know the post condition, then your first step should be trace some small examples through the code, like maybe on some small lists or some small numbers, and keep on doing this until you know what the post condition is. At which point, use the post condition. Okay, these next two pages aren't so much tips as they are visual representations of the kinds of analysis that you do for program correctness. This diagram is showing you what to do when you have on a program path a recursive function call. So if the black box is the recursive call, you need to prove that the input to the recursive call satisfies the precondition of the function and is a smaller input than the original. And then once you've proven these two things, probably using the original precondition, then you can conclude that the recursive call terminates and that you know exactly what it does because it satisfies the post condition. And I said in class that a common mistake is students will just kind of stop there and not really finish off their proof. So a tip that I will give you is don't forget about this part. Something happens after the recursive call probably, even if it's just a simple return statement. So you really need to use the post condition of the recursive call to prove the post condition of the original function call. So don't forget about this step. Here's what the diagram looks like for a simple loop. Note that the real interesting part of this is you have a loop invariant that should capture what the loop does. And if you remember, there are really three steps involved in dealing with loops. The first two steps, 1 and 2, they allow you to prove that the loop invariant is actually correct. what they do is basically a proof by induction that the invariant is always true no matter what loop iteration you're on. But then there's a third step too, and it's in this step that we show why the invariant is a useful one, why it's helpful, because it can actually be used to prove the postcondition. So one slight subtlety with dealing with loop invariants is that there's really an infinite number of loop invariants which are correct loop invariants, but there's usually only one or two or a handful that are helpful loop invariants that are correct and can actually help you prove whatever postcondition you set out to prove. Okay, hopefully you remember this from lecture. If you're using any of these words, either in your proofs or in your brain, you're thinking about recursion wrong. This one isn't so much a tip, but somebody asked me to talk about maybe different strategies you could use to study for this midterm. So on the left side here, I've basically written out all of the key skills that you need to have to succeed in this midterm. And luckily for you, they're all skills that you can practice on a wide range of problems. There are plenty of exercises in the course notes for all of these topics, but something else that you might want to try doing is just look up some basic software programming interview questions. Usually these interview questions aren't too hard. For example, max subsequence sum could be an interview question. So look up some interview questions, and for each question that you get, write a recursive algorithm which solves that problem, write an iterative algorithm that solves that problem, analyze their runtimes, and prove that they're correct. And the one on the right, I only really started thinking about it recently. I don't think most of you really know how to use posted solutions effectively to improve your learning. What you really should do is you should take the solutions that you wrote for a previous challenge or preliminary or midterm and read them side by side with my solutions. And you should do this even if you got perfect. Chances are high that my solutions are better than yours, and the only way that you can improve either the correctness or clarity of your solutions is to be thinking about them as you read mine. Even though I've said both correctness and clarity, I think this tip is especially valuable for people who are doing pretty well, but whose writing isn't actually that clear. And that probably applies to a lot of the people who are doing well. And yeah, that's all the tips I have for you. Somebody asked me to state the room numbers of the midterm on this video. Look on the course webpage. Thanks for watching and have a great day.